So this tutorial is meant to be an introduction to systems of linear equations. And a system of equations is when you have more than one equation. Often it's two, but it can be more than that. And don't have to be straight lines for it to be a system of equations, but in the grade 10 course in the province of Ontario that I'm writing these for, we're talking about two lines where we're going to graph two lines, and the solution is where they cross, where they intersect. So I've graphed y equals negative 2x plus 6. So that's this one right here. See, the y-intercept is at 6. Second, third, y equals mx plus b form. Slope's negative 2. So if we go down 2 over 1, there's a point. Down 2 over 1, there's another point, etc. And the second one is y equals x minus 3. So negative 3 is the y-intercept. And there's a 1 here by the 1x. So remember, 1 is the same as 1 over 1. So if we start here and we go up 1 to the right 1, that's a point. Up 1 to the right 1, that's a point. Up 1, right 1 to the point, that's a point right there. Now we're looking for where these lines intersect. And I'm going to show you algebraically how you find that, but using Desmos, see, I have my the black line highlighted here right now. So that shows me that 3, 0 is a point on the black line. So if I highlight the green one now, and drag my cursor down here, see, that tells me that that 3, 0 point is on both lines. So 3, 0 should be the solution to this system of equations. It's the point they have in common. It's the ordered pair, the same ordered pair that makes both equations a true statement. And I'm going to show you that. So over here, so there's the two equations, y equals negative 2x plus 6 and y equals x minus 3. So those are two, and it looks like the intersection point is 3, 0. And we can check that in the two equations like this. So in this equation here, now it's just y on the left. In each case, y is 0. Remember, x, y. So y is 0 for that point, and x is 3. So the left side of that equation is just the 0. The right side is the negative 2x plus 6 expression. So now my x number is 3 here. So I'm going to put 3 in place of x, and I'm going to evaluate this. So if I multiply negative 2 by 3, I get negative 6 plus the 6 on the end, and those are opposites the way they add to 0. Notice that this and this, the right side and left sides, work out to be the same thing. So we say that that 3, 0 point satisfies that equation. So let's check it in this one. The left side expression in the x minus 3 line is still just y, so it's still just the 0. Nothing to evaluate there. On the right side, we have this x minus 3, so I'm going to put 3 here in place of x. So 3 minus 3 works out to 0 again, and my right side number is the same as my left side number, so that shows that that point is also on that line. So the intersection point, the point they share, the solution to this system would be the 3, 0 point. Or you could say x is 3 and y is 0. You can state it either as an ordered pair or what x and y equal. So let's take a look at one more. So I'm going to just edit these. So different equation, I'm going to make the first one y equals x plus 4, and the second one I'm going to make it y equals 3x minus 2. So now let me just drag my graph down here a bit. So just graphing them, if you're doing this on graph paper yourself, the y-intercept is at 4 there. Slope's 1, so up 1 over 1. Up 1 over 1, there's a point. Up 1 over 1, there's a point. And the 3x minus 2 one, so negative 2 is the y-intercept. And the slope would be 3. Remember, 3 is the same as 3 over 1. So if we start here at the negative 2 y-intercept and count up 1, 2, 3 over 1, that would be a point right there. 1, 1. If we go up 1, 2, 3 more and over another one, that's another point, etc. So we could graph the line. So let's see here. Okay, so that's 3, 7. So if I take this line and highlight there. So 3, 7. It looks like 3, 7 is the intersection point for these two lines. So let's go back to another whiteboard. So here's my two equations. y equals x plus 4 and 3x minus 2, and I think 3, 7 is my point of intersection. There's the 3, 7. So let's check in these. And so in the left one here, the left side is just y again, so that would be the 7. Nothing to evaluate there. On the right side, we have the expression x plus 4. So I'm going to put that 3, because see, this is my x, the y is 7. So I'm going to put 3 in place of x, so 3 is going to go there. 3 plus 4. And 3 plus 4 certainly does equal 7. So my left and right sides do evaluate to the same thing, so that checks that that point is on that line. So let's do this one now. So again, 7 is the y, so my left side is 7. On the right side, so we're going to put that 3 in place of x here, so it'll be 3 times 3 minus the 2, and of course 3 times 3 is 9, minus 2 again works out to be 7, so that point is also on that line. And so that's the point we're looking for. We're looking for the point that's on both of the lines, so that is the intersection point. Where x is 3 and y is 7 is the point that satisfies both equations. It's the point on both of the lines. So that's what a system of equations is. You're looking for the place where the two lines, or you might have more than two, intersect in the same point. You're looking for the point they have in common. And that's the end of the tutorial.